Hello everyone, warm welcome to this webinar. And for next few minutes, I would like you to as we continue the journey, what we plan today. So after the end of the sessions, I would be expecting you to have a clear understanding of the digital twins, and we will also have interesting case studies through the topic, and it will be let's try to make it more interesting. And yeah, so let's go ahead. Before going to the topic, quick introduction about me. I'm a mechanical engineering graduate, and I've started my professional career with Tata Motors as a new product introduction. Then I moved to PLM, product lifecycle management consulting, and then I was in aerospace organization for manufacturing consultant, and then I was in UK for Airbus, one of the landing gear architect, and currently I'm in JLR as an operations lead. Uh, so, so coming back to the digital twins, so before going to there, why we need any transformation, and any organization in today's entire world, we see the product companies we called OEM, original equipment manufacturers, without having a transformation. See, transformation is something related with the data. So an ability to use the data rightly with the valid data sets, which can give organization insights. So that is a simple definition of transformation. And the vision is sometimes it changes, depends on the complexity of the product, and it depends on what are the short, medium, and long-term goals. And it is also what is the pain point organization really try to highlight. So all these technologies you see in digital uh, world today. So because we are living in a dynamic world where environment is changes, our geopolitical situation change, the way manufacturing is being designed for manufacturing, and the product engineering is completely different what it was there 10 years ago. So this is what we I would like to set the context of transformation, and digital twin is one of the technology uh, which which we are going to discuss. And see, coming to the overview of this thing. So digital twin. Um, so in currently 2023, the global digital twin market valued at 12 billion US dollar, and it is projected to be at around 259 US billion dollar by next 5 years. So it is around 39% of CAGR, which is compounded annual growth return. And this is where we will also see some interesting numbers. And just have an overlook in 70s cars, which is purely a mechanical. Then coming to the mid 90s, we it depends on the so US, if you consider the United States, most of the cars and manufacturing, they are electronics were introduced like Bluetooth, then the car parking, reverse parking, then the reverse parking sensor camera. So it's a connectivity get introduced, and then currently almost all the people who are listening the webinar, they are driving means they are driving the cars, which is mostly computerized. So you have various smart devices, your connectivity improve, uh, your voice commands is there now. But just by telling the voice command, you can able to play interesting music or listen to the podcast while you are driving, and it much more than the simple driving things. So that's where, see, initially it was no software, only mechanical things, and in the mid it was growing electronics, and right now it is more about uh, computer on wheels. That is the right term to mention. So it all about electronic sensors and those things. So to outline the session of today, what I have planned for you is we will see a digital twin definition. So I would like to be very clear on this session. I plan to be uh, informative and overview of this session. Uh, so it's an overview, and we will try to become simple as possible. Then we will see the evolution, how digital twin evolve, and we will also see the definitions, a product of feature of the product, what are the key features, and then we will see the implementation. So how the digital twin get implemented. So so let's have a look around what we are discussing here. So predictive maintenance. These are some of the key technologies. So to highlight what are the technologies currently for manufacturing, because our session is related to the manufacturing. So you can see the trend. So this is the data from 2020, and you can clearly see digital twin factory, which is now currently 19%, and it is growing plus 25% in next 5 years, and it will be 44%. So digital twin factory, production asset, and the twin of the product. So you can expect digital twin is going to be much utilized as we have seen previously by 2031. So 43%. So more and more companies now are aware about this terminology. And digital twin, now we will come to know. Before that, uh, I would like to give an overview. So where this term basically arises. So in 2003, Dr. Michael Greaves proposed the virtual representation in his thesis, and where he come up with the terminology VDR, which is nothing but a digital copy. And then in 2006, the U.S. National Science Foundation first proposed this the information about cyber physical system. So this is the timeline. And in 2011, again, Michael Greaves' book is Virtually Perfect Driving Innovative. So this is his books, and where he mentioned about the PLM, Product Lifecycle Management. So where he first time made the noun digital twin model in 2011, and also in US Air Force Laboratory, so digital twin was proposed for the development. And see, US Air Force Laboratory, they have come up with their pain point of maintenance, solving the complex maintenance, because aircraft and airfield, they work with a very different confined space, and sometimes remotely the maintenance has to happen for maintenance and overall for various parts of the aircraft like engine, wings, propellers. So, coming to the digital twin definition. So first is what you need for building a digital twin. You have to have a physical product, physical, that is a real part. Then you have to have its virtual counterpart. And these are the two key elements. And the next thing is you have to have data and information flow, which is a key area which separate the physical and virtual world. So digital counterpart is required, and for that you have to have something virtual in physical object. And so there are three key definitions or subset, I would say. One is digital shadow, digital model, and digital twin. So all these key examples will fall into this area. So moving back in 2013, so there is in Germany, they have proposed Industry 4.0, where the core technology is cyber physical systems. And Germany, they wanted to come up with means communication, control, network, and physical environment. And on the basis of this modeling, the physical entities and physical space reconstructed, and digital twin ability and perception. So Germany come up with the Industry 4.0 term in 2013. And then again in 2014, Michael Greaves published a digital white paper or digital twin. And the real breakthrough happened when 2015, when General Electric company, they have come up with their pain point for real-time monitoring for inspection of the uh, uh, for the engine. So that we can see here. So uh, so the gas turbine, what they have done is, so General Electric, they tried to replicate the model of the engine. So all this you can see here KPIs. So atmospheric data, operational data, inspection, repair, site data, and there are various sensors uh, put it around the physical object. With help of that, the real key performance indicator get managed. And this you can see a digital power plant. So this is where in last decade, digital twin technology started, coming up, and now it's more many organizations are utilizing that technology, which we will see through the example. So this is one of the historical record. And then in 2016 and 17, Gartner, they have consistently come up digital twin as a top 10 technologies trend. So, so 17 for consistently 2 years, this technology, one of the top consulting firm has put this as a top and beneficial technology. Now, coming back to the definition of original definition. So, digital twin, we will don't have a, a, a definition which is widely accepted by everyone. So, one of the definition is it's a exact replica of physical object in digital world with real-time connectivity. And with this example, I would like to give you an overview how the digital twin definition is different. So, for example, Cambridge Center of Digital Technology, they refer digital twin as a realistic representation of something physical. Then Dassault Systems, they are a key players in technology. They refer digital twin as a virtual representation of what has been produced. So as manufactured and as designed. Then Deloitte Consulting mentioned it's a real-time digital image of physical object that helps optimizing the business performance. So Deloitte Consulting trying to connect the pain point and business's performance, which is like return on investment or 20% improvement into the productivity, that kind of term. So, and then General Electric mention, as per General Electric, digital twin is a living model that drives the business outcome. And obviously, you can see IBM. IBM says virtual representation of a physical object using real-time data to enable reasoning, learning, and close understanding of the model. And we have Siemens. Siemens is also a digital twin software company, a platform. They, as per Siemens, virtual representation of physical product used to understand and predict the physical counterpart performance characteristic. So after seeing all these definitions, uh, what is the close definition? There is no realistic definition, but uh, mostly what is accepted definition of digital twin is it is refer to a process, method, and tool with certain characteristic and behavior which form and improve the performance of physical object that we have seen in the previously. So you have to have physical object, you have to have digital object of that, and you need some connectivity. and it corresponds to physical entities. So, for example, if the flow, for example, if it is a pump, then what are the fluid characteristic? So, what is the density, and that kind of physical modeling is required. And also, if coming to the manufacturing world, physical factory, uh, physical factory, it can also have a factory digital twin. So, so this is the realistic definition of digital twin. It has a modeling of the characteristic, it has a behavior, and it has a formation process. So before that, now I would like you to think about, means everybody, means those most of the people on the call right now, uh, they have used the Google Map. So so Google Map is a perfect example of digital data twin. So imagine you are planning your travel and you want to go from point A to point B, and you open the Google Map and it will show you the exact direction, and it will also predict if you follow this path, what are the hurdles you will get. And if you follow this path, it will be much quicker. It will also show you 9% or 9 minutes, 9 second uh, quicker. Or it will also show you if you go this route, you will also see a red mark on the road. And that is the power of that. So it is a digital data twin and it is a prediction. So it gives you and it helps you to take smart decisions. So a product twin, it's you can see this is a example of the CAD model of a product. So which is a car in this case. Then a data twin nowadays, there is a highly aspiration going on about digital twin of the earth, so which is another topic. But these are the ambition. There is a team who are working on digital twin of the earth, so which is quite complex and huge task. So and then system twin. So systems are uh, basically it's about your it comes with various combination of your lines. So if it is a robotic line, so you will have various robots logically assembled on the shop floor, and you will have a scenario for building line, zone, station. Those who are from mechanical engineering, they understand this. And infrastructure twin is something like Singapore, the city they have built, and it is built on the concept of digital twin. So they have exact city replica, and various through help of various sensors, the city is being constantly updated into a model. So these are the types of digital twin. Uh, so giving you an example of Formula One. So in Formula One race, which is another perfect example of infrastructure twin, where you can relate this with games also. Perfectly, the, the track of a similar location gets simulated, and infrastructure twin get built, which from that the the participant and the sponsorer and the companies can take smart decisions. Where is the corner of the road, where they can improve the speed of the car, and to gain a competitive advantage. So that's how infrastructure twin helps, and obviously it has various benefits. Uh, uh, so these are the types of digital twins. Now moving to the, I hope the digital twin definition is now clear. So you have to have physical part and you have to have digital part, and there is a connection which is the seamless and ongoing connection. So what are the features. Now there are multiple features of digital twin, as you can see on the slide, where there is a physical product, and on the left hand side it exact replica. So one of the important feature is multi-physics. When we say multi-physics, it has many uh, key attributes like stress analysis, then fatigue and damage control, structural dynamics, and before vehicle get launched for the customer. So, so it normally take 2 to 3 years to build the car for any manufacturer from scratch to production. And before that, or the manufacturer will go through various types of analysis. You know, first there is a concept, then there is a design, and then development, and then proto build happen. So proto design, you can shrink the time. So proto, there are multiple tests happens. So impact testing happens. So vehicle coming from 200 miles per hour, and it get have a crash. And what are the parameters uh, for the drivers? So and how it impact that has tested rigorously, and that is how one of the feature is multi-physical. The composite materials such as stiffness and uh, the styling, the weight of the part. So it has those shape, size, and tolerance. So it is one of the feature of digital twin. So it is a multi-physical which can be modeled. Second is multi-scale. Uh, when we say multi-scale, we have to have the geometric dimensions, and is also come up with some properties. For example, for aircraft, composite material is more used, and carbon fiber. This is expensive because aerospace industry go through top level of governance and policy. So there are strict rules and governance for aerospace parts, whereas for automotive, it is different. There are some standards which company has to maintain, depends on the geography where it operates. And the next is hierarchical. So what are the features of digital twin is one is so different components, as I said previously, the final product is an aircraft. But for aircraft, it has a multiple layers before it goes to the top level. It has system, subsystem, and components. Like like you can see for aircraft, you have engines, then wings, then then vertical tail. Then you have another engine as a backup. You have a fuselage. So section is divided into three. So front fuselage, middle, and rear, and propulsions control system. So these are the features. So digital twin, we will also see that in coming slide. So progressive realization of the product digital twin model, it depends on the complexity and the area where the pain point is. Another thing is the dynamic. The product digital twin model will constantly change and improve. That is how, which is one of the key features. For example, if I am building a digital twin of one of the bridge, I imagine. So on that bridge, what what are the conditions of today? Today, if there is a wind coming and there is a storm and rain happen, and after 3 days, it might be environmental condition change, and there will be a big weather change, and those conditions will not be the so. I need to adapt those historical data into my model. So I have given a bridge example, which is also uh, similar to, let's imagine on the road there are signals, and you are developing a digital twin of the traffic systems. So on that traffic systems, the conditions of the weekend and the condition on the peak hours of the office are different. So that is the environment in which it operates. So it constantly change, depends on the nature and the depends on the usage. So this is one of the key feature of digital twin. It's a dynamic, and also like product manufacturing data uh, such test data and process progress data will be reflected in the twin model. So in a summary, this models needs to be constantly evolved, and based on that, the digital twin can make a smart and predictive decisions. And also, visual monitoring of the manufacturing state is something uh, the organization or the company and all these twin models. So it is where it is based. It is into the computer. So whatever we are talking about the twin, it resides into the computer, and based on that there are prediction. There are with help of artificial intelligence. We can. I will quote a term here that playground. So it's a perfect term to say. So playground, which helps you to uh, uh, put some parameters. Those parameters can be extreme. Those parameters can be moderate or low, and based on that, you can predict. And in that breach case, when what is the maximum load the breach can take? So that is also you can predict with help of those data set. And for example, the Waterloo Bridge in London. Uh, so it's going on from 100 years. So, and it will go for another many years. So unless you put the historical data to it, you can predict that. So you have to have a digital model of Waterloo Bridge or any bridge, let's say. So you once you have that model in your digital world, and you will provide the data, and you will have sensors on that bridge. So those sensors will capture the real-time information of the load, temperature sensor, pressure sensor, humidity sensor, uh, multiple types of sensor. It depends on the uh, the the area which you would like to understand. So it is dynamic is one of the feature, and these are the also some feature like multidisciplinary. So it has to have information related to mechanical engineering, electronics, physics, and we will see that multidisciplinary. It also connect with MBSE, model-based system engineering, and why this multidisciplinary feature is one of the core feature because because we operate in a world where we have to have a um, uh, uh, because we have considered the aeroplane. So in aeroplane, there are hundred of subsystems like ATA chapters, engine, then electronics, fuel. So it also applies to car. So imagine a car which contains several other technologies and several other disciplines. Like you have steering system, you have seating system, then you have uh, then a styling studio, designing, and unless all these discipline comes together and form a core backbone of the model, and which have completely reflect exact discipline, then that's the reason it is called as multidisciplinary, one of the feature. Then computability, so it should be lightweight simulation, and it will be a probabilistic. So digital twin can be predicted, as I said. It can be extreme, a playground. It can be act as a playground. Now coming back to the implementation part. So, so uh, digital twin has certain states. So far what we have seen the definition of digital twin. We have seen the historical how it evolved from 2015 to till now. We have seen multiple types of digital twin. Uh, so, uh, so to ensure the accuracy of the simulation and optimization of result, so uh, below three areas are important. So first is you have to have high accuracy product model, which we have discussed. Then it has to accurately. So now it depends the model which you created. That model has to represent at least 90, more than 90% of the state. It should be lightweight. So because in manufacturing, this lightweight, why it helps? Because downstream usage like extraction of geometry, then it can be easily stored, and multiple file size can be accommodate for the next usage. So so product design state of the twin, then then production state. So the evolution of product digital twin is via constant interaction. So what happen is in production state, the production process monitoring, and one of the key pain point is you never know which machine and which line will get stopped. So as I'm coming from manufacturing background, being a car company, they have to deliver cars every 60 seconds. One car get roll out. That is mean by so 1 minute is a takt time for a car. So every 1 minute there is a car being rolled out. So so this is why uh, the prediction is important, and you will have with help of digital twin we can easily track what is the exact uh, area, like in this case it's a robot or a machine which is going to be perform, and which machine having exact failure, and which machine also for example when it comes to maintenance, what is the after a certain period of time, what are the parameters it will break. So that is also with help of digital twin we can one can able to predict, and with help of those monitor system provide the alert, and with that alert one can change, for example bearings can be changed after certain period of time, and those respective decisions can be taken. So implementation of digital twin, I'm here, I'm coming up with the example. This is a very simple example of control systems, where you can see it's a very basic things. Here it's a pulley and it has certain mass and it's a table. So it's a control systems which designing a system which is an electromechanical system, and with help of this example we can understand the digital twin. So it has a linear displacement sensor and it has a torque, and as mentioned earlier, so first thing is we have to model, and which is a block diagram. So uh, so modeling of the control system, for example it is a current, and you can see here so torque and armature current. So what uh, I'm trying to show you is it has a certain mass, and the force is equal to F is equal to mu n. Mu is a coefficient, and this is a simple example. So if we have to pull this uh, a fastener here bolt, so what type of linear displacement force is required, and you can see here uh, with help of, and this model will also change. Why it change? Because the frictions is also get changed, and it is get mentioned here. So one has to design this model. First step is you draw this diagram, you get a sign, then you can put the sensor, linear displacement sensor, torque sensor, and those information get constantly updated with help of here. So this is a simple mechanism of a digital twin. So ultimately, uh, this is get modeled here, and you can able to predict uh, what is the current supplied to the motor here. So this is a simple example of digital twin implementation. Obviously, it is a based on the complexity. You can have a model, and that model can be with multiple disciplinary. That model can be created, and the connectivity get introduced. So now coming to the important part, which are the key technologies which enable digital twin? Now, out of several technologies, uh, there are four key technologies. As I have given a reference, so first is model. You have to have a model of something which is a 2D model or a 3D model or a business process, a block diagram. So that is the first point. So this is a very important key slide. Then you have to have connectivity. So unless there is a connectivity mechanism, which with help of that data transfer happen, and there are a lot of connectivity tools, then you have to have sensors. Then cyber security. This is one of the key important technologies which makes digital twin operate in a efficient manner. And obviously, you have some optional technologies like virtual reality, augmented reality, and mixed reality simulations, which is generally simulation is a static state where you don't have a physical model. You don't need physical model like digital twin. You have to have digital model, physical model in order to have digital virtual world. Simulation is one of the optional technology enabling. Then big data analytics. Now each of these key technologies, but these are the four, the baseline. So whenever you talk about digital twin for a product, process, component, or uh, or a people. So nowadays there is a people digital twin is also there. They have to have these four key things, and all are key important. First is baseline model. Model can be a MBSC, and it can be designed. Then model have to have some connectivity. Then you have to have sensors. When it comes to sensor, there are various sensors. So basic like temperature, pressure, then transducers. So those sensors, they capture the physical image and they send that signals to the virtual world. And cyber security nowadays is very important because cyber security, one of the key example is single sign-on. Like you all work on a different areas, different organization, and different business world. So this is one of the key topic that many antivirus get installed to detect the malware, uh, to stop the cyber attacks. Nowadays, we are living in a world where cyber security is very important, because it can stop. In the UK also, only last year there were three big cyber attacks, and which information available in public domain, like Mark and Spencer. Then London Heathrow Airport, they also have a cyber attack, and all the key bookings, airline bookings have stopped. So we are living in a world where the anything can happen. So it all depends on how resilient planning, how resilient pre-planning is required, and that's where this cyber security is a important and a must part of this. So now, what are the applications of digital twin? Uh, so applications, when applications are in a wide scope, it is depends on what are the pain point of the uh, um, area. So manufacturing company will try to solve their pain point by having a uh, target of 20% improvement in their product ramp up. Means they are delivering X amount today, 600 cars. They want to deliver 700 cars. So that is one of the key uh, application that okay, they can able to produce more cars. So that is a efficiently optimized way. And in terms of medical or that devices, they have different ambition, like how the heartbeat of the patient, so digital twin of heart. So how they can clone it in terms of giving all the inputs of a human body and how that can be replicated or given condition like blood supply, how that heart behaves. So uh, so that is those are applications related with the different field of uh, area. So then this is one of the application like product design, uh, because I have mentioned previously, proto build is one of the key part. So while designing the product, it goes through numerous cycles before the design get finalized. For example, famous example is any model of the car which we can see, but before that there are hundreds of uh, examples or hundreds of trials and errors that has to go through. So with digital twin, it get easy because you can able to one can able to simulate it, and all the uh, working department like design, quality, manufacturing, service, they can collaborate and make smart decisions. So that is one of the application. Virtual prototype, which we have discussed, that having a virtual prototype, it can help you to decide and make the combination. Like if I put the seats in the car, so before seat I need to have carpet, or uh, I need to have steering wheel or not. So these are process. This is unless there is a car seat, whether the car seat to be inserted first and then steering wheel, because and whether there will be a wiring harness, which is a wiring network, that wiring harness to be laid out first, or so that is how the planning happens, because first you need to have certain set of component to be assembled on the car, and you have to have engine and chassis marriage. So these are, you can able to take these calls, and also you can see here, you can also do with help of this prototype based digital twin. It is allow you to uh, a playground, as a playground. It can act as a playground. So where you can do the thermal test, other various type of trait, homologation testing. Then you can also uh, perform those with help of, you don't need a physical model, don't have to spend money on it, and that's where virtual prototype is really helpful. Uh, so there are certain other areas where digital twin play important role. So in manufacturing, we have seen rapid design. So if you have a digital twin, so it helps into quick design scenarios, scenario 1, 2, 3, and it helps you to select the right level of design. Then process planning, as I mentioned, uh, first we all see the cars to name Mercedes-Benz, BMW, Rolls-Royce, and they have their own badge, own logo. So process planning is all about when and at what sequence that operations comes, like when to fit the glass, when to fit the wheels, when to assemble the fuel tank, when to assemble the car hood, for example. Uh, so this is all about the process planning. How, and there are around 30,000, more than 30,000 parts in a car, which comes and which assembled and for it is a car. So that ability one can one can get process planning. So how effectively you can plan the process so that within that particular time it can get fitted. So this is corely manufacturing term. Then production scheduling. If you have a right digital twin, it also help in scheduling, production scheduling based on optimization on digital twin. So once you have a digital twin, you can play with some scenarios. Obviously, logistics. For example, in a building where you have uh, space for everything, for space for machine, space for your manipulators. These are the terms. Space for people to walk, space for truck to enter, put the goods, take the goods out. You can plan those scenarios virtually with help of digital twin. So you can take smart decisions. And man-machine interaction based on the scenarios. For example, for a car company, a robot used to quickly, so for body in white, so body in white, nothing but the skeleton of the car without having any component. Imagine only frame of the car, and that is being welded by thousands of robots. So that interaction can be improved. And here in particular case, man machine comes where there is a, for example, for paint case. So companies like Rolls Royce or other premium car companies, sometimes they also use manual methods. So that can be easily carried and efficiently done by man-machine interaction. For example, uh, also a two-wheeler company, many companies they handly painted the fuel tank of bike. So how that optimum paint can be used, so that man-machine interaction can be improved. And detection, testing, detection, and production quality. We have touched this part. Imagine before taking any step, your machine give the prediction that okay, failure happens after thousand of cycles. So that kind of testing detection with help of sensors, digital twin is capable of completing this. So yeah, quickly. So three things to keep in the mind. First is what is the purpose? So you are building asset, product, or combination. So what is your pain point when you are building a digital twin? You have to have purpose. If this is missing, then digital twin purpose get lost. For example, uh, you have to have pain point. What is your targeting? Where the digital twin fit? So here I have mentioned here means building information model, CADs, sensors, creating a 3D model. So this is a key part. So just to revisit, you have to have real world like aircraft, then you have to have yes, its virtual representation, and then what connects is your continuous two-way data flow powered by sensors, and IoT is nothing but Internet of Things. That makes your digital twin. And there is a term which is very popular called as digital thread. So that is how the data get collected. So and then based on that, you can do the information and make smart decisions. So these are this is going forward. Digital twin can be a supervisory, interactive, and predictive. So mostly, since I come from manufacturing department, manufacturing engineering, in our field, predictive digital twin are mostly used. So because having ability to predict, and in aerospace industry also, this prediction, to name a few like Rolls Royce, General Electric, Maserati in automotive, they have this predictive digital twin already established and they are already using it. So it's no more a buzzword, it's a real scenario, and some things are really happening and it's constantly evolving. So it can be more or less complex depending on the goal of the organization. So we have seen this process twin, system twin, asset twin, and component twin. So So component we have seen bearing, piston, axle. So these are engine parts. And the maturity, this is very important. So it depends. So autonomous, like you all know, Tesla has an autonomous car, and every Tesla on the road, every Tesla running, they have their digital twin, and they collect their own information, such as battery consumption, such as fuel, in case of uh, no, accelerator, brake, clutch, what are the parameters. So Tesla has all those models, and so they have digital twin running for every car. And as we have seen, comprehensive, predictive, informative. Sometimes you just need a dashboard with some analytics. Uh, so key performance indicator. So for example, if I want my X building, what are the uh, how many cars get produced today for 1 hour? So I can see that. So that is a informative digital twin. So I can get that dashboard. These are some of the maturity. And see, these are the basic subtypes which we have touched earlier. So digital shadow, which don't have the automatic flow of the data. Then digital twin, obviously it has two-way flow, manual as well as say automatic flow is there in both physical as well as digital model. And digital shadow, which has automatic data from physical to digital part. So whereas the manual is there from digital to physical. So these things are, remember. One of the example of digital model is our CAD files, simple models, simple design models. Then digital twin example we all have seen. So first is digital model have lowest levels of data. So there is no integration, no complexity. And so these are the implementation step. So initiation. So as Stephen Covey said in 7 Habits of Highly Effective People, begin with end in mind. So starting point will be your initiation. And I know some of you, as we coming to the end of the session, some of you have asked some questions. So first step is understand what is the pain point. Then you have to model either help of technology like block diagram, and then you have to see the connectivity, and uh, then the ongoing development happen, and reuse. These parts is not heavily used today. So I'm not touching the system engineering, but just to give you an idea, you see human body, because of multidisciplinary approach, I'm able to sit on this chair and able to communicate with you and able to deliver this webinar, because all these parameters like nervous systems, then respiratory systems, those systems are very well aligned. And it same goes with automotive industry, because it needs more system engineering, because it has multiple disciplines like mechanical, electrical, electronics, software, and that is how your modeling will come to the picture. So as strong your model is, your digital twin is more efficient. So INCOSE is a body which governs the system engineering principle. So SysML is one of these are the some of the running areas where modeling can happen. Magic and Cameo, these are the tools which helps you to do the system engineering, SysML. So these are some of the multiple disciplines where applicable to cars also. So mechanical, you have to have CAD. So this is a skeleton CAD. Then electronics will happen. Then electrical. Then you have to have software. Then networks. So CAN, and all these areas form your car. So it depends your model of the digital twin. You have to have separate twins for each area, and that's how those communicate with each other. So now we have come to the end of this session. So what are some of the means, as we wrap up, what are the benefits? So predictive maintenance, as I said, so with help of digital twin, so 30 to 40% improvement in terms of longevity. So for example, General Electric, they have a twin, operational twin, which predict this. Then virtual commissioning, line optimization, which is, as we said, uh, the manufacturer, the big companies, OEM, they can able to take smart decisions, and they can able to shift the line. To give you an example, Airbus A380, which is not there in the sky now, but with help of their own space, Airbus A320, now two more lines of A320 is been already occupied. So same space, so another product line get occupied, and that's how the line optimization can be done with help of digital twin. And it also helps in trainings. So whenever there is a remote area, so with help of VR, full body motion tracking sensor, operator can give the direction to the team, and they can work remotely. So yeah, and yeah, so this is one of the example of digital twin. So you can see the shop floor and RTLS. The main goal is tracking. One can able to track where the part is, and these are some of the key areas with help of tag, access point, and this is the model of digital twin, which is a supervisory. Another example is a process digital twin, where you have your processes, and you will get a dashboard. So you will come to know what are the process running on the factory floor. And this is also a paint shop example, where you monitor how much paint is there in the tank, how many cars it can produce. Such type of interactive digital twin you can make. So this is the dashboard. So this is one of the example of the twin. And these are the key companies of digital twin, like Siemens, Atos, Dassault Systems, and it all depends on your aspirations, the implementation. So this is one of the references which I have taken from the book. So this is the book, Digital Twin Approach to Improve Machine Tool Lifecycle. So this is the reference which I would like to mention. And as I mentioned, so General Electric, they have GE90 jet engine, every jet engine running in the sky. So they have real-time monitoring and predictive maintenance. Digital twin is running. And yes, so I would also like you to see this information, where I have mentioned how the space constraint, like aircraft is being assembled in this only 4 stations. Okay, so 1, 2, 3, 4, and this is the real scenario of complexity. So digital twin helps into this. You can able to see where your components can travel, how you can see here wings are coming, and you can see the how the constraint being occupied. And this is one line, this is another line. So similarly, how organization can have this twin for for various analysis purpose. So in this slide, you can see for those who are from manufacturing background, mechanical, we can able to identify what's going on in each image. So this is one of the key example. So this is Dassault system Delmia, which is, and with help of this twin, you can make a smart decisions. So you can provide. So here you can see how the operator is coming, how he is lifting. So this is production optimization. This is in static state, but this is as a connectivity reference with the digital twin. You can see here, this is the model block diagram, which is the first step before building a line. And you can see here how its maturity. So then you can see here the logistic box are moving, and you can here see the component, the piston. So you can make a smart decision. You can play with this, see the visualization, see the styling of it. And now, yeah, so I would like to take a pause now for question and answer. And there are some questions being asked. So now I would like to take a pause. So you can pose the questions, and definitely when time comes, we can answer it. So one of the question which is asked is what are the government policies for digital twin? Can be what government policies can come? Uh, so I would say it can be more in terms of data sharing norms can be introduced. So that is one thing, and more standardization because data is very scattered. There are various type of formats available. So that is one way to do universally accepted implementation standards can be bring. So this is one of the example. Means one of the government initiative. You can always feel free to put some questions. So this is where I would like to simply give an overview, awareness session on digital twin. And obviously the modeling part and connectivity part is core of digital twin. And that can be, I wish you, if you are exploring, so stay connected, ask questions, then we'll see how to address that. So thank you for listening to me. And we are coming to end of the session now.
Yes, indeed. The time just flew by, Sandeep. Thank you for that wonderful presentation. But we must now bring the webinar to a close. So I'd like to thank Sandeep for sharing his insight with us, Tata for making the event possible, and of course the audience for joining. An on-demand version of the webinar will be available for you as soon as possible. But for now, thank you so much for listening, and goodbye.
Thank you.